All right, let's do some more practice evaluating definite integrals using the fundamental theorem of calculus. Now, if you feel like you've got this, feel free to stop the video and try these on your own and use the video to check yourself. But I'm going to go ahead and walk through these definite integrals. So the first one, we want to evaluate the definite integral from 0 to 2 of 6x squared dx. Okay, so the first thing we're going to do is find the antiderivative of 6x squared. Now we're going to have 6 times x cubed over 3, but I can cancel that 3 and I'll make it into 2x cubed. Okay, that's the antiderivative. And 2x cubed. And I want to evaluate that from 0 to 2. All right, 0 to 2. All right, now I'm going to evaluate the antiderivative at 2 and then subtract the value at 0. So I'll have 2 times 2 cubed and then minus 2 times 0 cubed. Now, of course, 2 times 2 cubed is 8, and then I'm take that times 2, I'll get 16. And of course, 0 cubed is 0. Anything times 0 is 0. So my answer is 16. All right, let's try the next one. The antiderivative of t cubed is t to the 4th over 4, right? And then I want to just evaluate that from 0 to 2. So first thing I'm going to do is plug in 2. I get 2 to the 4th power over 4. And then I'm going to subtract 0 to the 4th power over 4. Now, of course, that second term is 0. And so 2 to the 4th is 16 divided by 4 gives me 4. All right, easy enough, right? Let's keep going. All right, so the next one, I want to evaluate 8x plus 5 and the definite integral of 8x plus 5. So the antiderivative is going to be 8 times x squared over 2. So I'm going to write it as 4x squared. And then the antiderivative of 5 is 5x. 5x. Okay, 5. Okay, and I'm going to evaluate that from 1 to 2. Good grief. Okay. All right, now I'm just going to take 4 times 2 squared plus 5 times 2. And then I'm going to subtract. Now I have to subtract the whole thing, so I'm going to put parentheses around it. I get 4 times 1 squared plus 5 times 1, right? Now, I have to put parentheses around it because I'm subtracting the whole thing. I'm subtracting the whole thing. All right, let's see what we get. So I have 4 times 4, which is 16, plus 10, and then I'm going to subtract 4 plus 5, okay? So that's 9, so I get 10 minus 9 is 1, and so this turns out to be 17. 17. All right, one more. Let's see. We're finding the antiderivative from, or finding the definite integral from 0 to 1 of 8e to the 2t. So I'm going to get 8 times 1/2 e to the 2t, so I'm going to make that into 4, because 8 times 1/2 is 4, and then e to the 2t, and then I need to evaluate that from 0 to 1. Okay, so now I just need to plug in those values, right? I'm going to plug in the value at the upper limit, so I'm going to get 4e to the 2 times 1, so I'm just going to write that as 4e squared, minus 4e to the 2 times 0, which is 0. Now e to the 0 is 1, so what do we have? We have 4e squared minus 4. Now, if if you need the exact answer, this would be considered the exact answer. Now, if I plug that into my calculator, I can actually get a number. So this is approximately equal, if I express it as a decimal, it's 56. All right, so that's approximately equal to 25.56. All right, that's it. I'll see you in class.